So let's look at another example involving equivalence classes. So let's look at the following. Consider the equivalence relation defined on Z by A is related to B if A equals B. So if I look at any element out of Z and I look at the equivalence class for that element, remember this is the set of all elements in Z where X is related to A. But what is our relation here? Our relation is given by A equals B. So this is the set of all elements in Z where X equals A. Well, there's only one number, one integer that's equal to A, and that's A. So for this relation, I can say that every integer is in an equivalence class by itself. So if I look at my equivalence classes here, my equivalence class is a set with just one integer in it, the integer A. So every integer is in an equivalence class by itself. Let's look at another example. Let's say a relation is defined on Z by X relates to Y if the absolute value of X equals the absolute value of Y. I'm going to go ahead and tell you that this relation is also an equivalence relation. So you can show that this relation is reflexive, symmetric, and transitive. And now what I want us to do is talk about the equivalence classes for this relation. So if I take an A in my integers, and let's look at the equivalence class of A. So remember that this is the set of all X in Z where X is related to A. So this is the set of all X in Z where the absolute value of X equals the absolute value of A. And so now there's two different possibilities. So if A equals 0, then your equivalence class will contain all the integers where the absolute value of X is 0. Well, that's just one number, that's 0. And if A is not 0, then your equivalence class of A contains all the X's in Z where the absolute value of X equals the absolute value of A. There's going to be two elements in this set that have absolute value A. It's A and negative A. So these are our two possibilities. We get the equivalence class of 0, which just has 0 in it, and then the equivalence class of any other integer, A, not equal to 0, will be a set with just two elements in it, A and negative A. So those are my two different possibilities for my equivalence classes here.